Quadratic Equations, the square root property. In this module, we are taking a look at how to solve quadratic equations. That is, equations of the form ax squared plus bx plus c equals 0, where a does not equal 0. Or if you like, polynomial equations where the highest power or the degree is 2. Now in the first topic, we discussed the factoring method for solving quadratic equations. This helps us to solve some quadratic equations. However, unfortunately, not all quadratic polynomials can be factored. So that means we have to develop other methods, more comprehensive methods, to solve quadratic equations. The square root property, which we discuss in this topic, is just one of those methods. It's a step along the road to solving any quadratic equation. To introduce the square root property, let's consider some examples. The first example, find all solutions to the equation x squared equals 9. Now let's just use our intuition to solve this quadratic equation. In order for a number to be a solution to this equation x squared equals 9, it means that when we take that number and square it, our answer is 9. Now, can you think of two numbers which when squared gives you 9? Well, two numbers that fit that description are 3 and -3. 3 squared is 9, and -3 squared is 9. In fact, these are the only numbers on the number line that can be squared to get 9. So this is our solution set, -3 and 3. It's important to notice that the solution set of x squared equals 9 consists of both the positive and negative square roots of 9. Let's take a look at a second example. Find all solutions of the equation x squared equals 5. Now, once again, a solution to x squared equals 5 will be a number that when squared gives us 5. Think, what times itself, or what squared gives us 5? Once again, there are two answers, two numbers that fit this description. The square root of 5 and the negative square root 5. Because square root 5 squared and negative square root 5 squared both give us 5. Therefore, our solution set consists of the two numbers negative square root 5 and square root 5. Again, we see that our solution set to our quadratic equation x squared equals 5 consists of both the positive and negative square roots of 5. This is the idea behind what we call the square root property. The square root property is as follows. Suppose q is any variable quantity and k is a non-negative real number. The square root property then states if q squared equals k, then q equals the square root of k, or q equals negative the square root of k. In many books, q equals the square root of k, or q equals negative the square root of k, is condensed into the shorthand notation q equals plus or minus the square root of k. Be aware that when you see this statement q equals plus or minus the square root of k, it encodes two separate equations. It means q is the positive square root or q is the negative square root. Note the square root property can be applied to solve quadratic equations that have a squared quantity equal to a positive number. In other words, the square root property applies when our quadratic equations are of the form quantity squared equals k. Here are some equations that can be solved by applying the square root property directly. Here we have x squared equals 17, a quantity squared equals a positive number. Here we have x minus 1 squared equals 4. Again, a quantity squared equaling a positive number. 1/5 x minus 1 squared equals 10. Again, a quantity squared equals a positive number. In each of these examples, we can directly apply the square root property. To recap, in this topic, we are looking at how to solve quadratic equations of the form q squared equals k by using the square root property. There are several things to remember. First, the squared quantity in a quadratic equation must be isolated before the quadratic property can be applied. Our equations must be of the form quantity squared equals some positive number. Second, the square root property results in two new equations. Do not forget the negative case. Remember, when we solve these, we get two answers, positive square root and a negative square root. Third, if a quadratic equation has an unsquared term or a middle term, the square root property will not apply.